All right. Hey class, Mrs. Anderson here. This video is going to cover cosine function graphing. It's the second part of 11.4, so 11.4b. Hopefully you've already watched the video on graphing sine because it's going to be very similar, and I go into a lot more detail with that one. So here we go. I want to focus just on the main 4 points of the unit circle and remind you of some key things. So the unit circle makes a full 360 degrees. So at 0 degrees, you have the point 1, 0. At 90 degrees, or pi over 2 in radians, you have the point 0, 1. At 180 degrees, or the point -1, 0. And remember, 180 degrees is pi radians. You have the point -1, 0. And 270 degrees, or 3 pi over 2. So really you're counting by halves all the way around in radians, or pi over 2s, I suppose. And then this point is 0, -1. And those 4 points are important because those are going to follow they give our trig values for cosine and sine. So I remember that cosine goes with x and sine goes with y because it's in alphabetical order, just like x, y is in alphabetical order. So we have cosine of theta and sine of theta. And so cosine of 0 degrees starts out at 1. And then cosine of 90 degrees, or pi over 2, is 0. So as our theta gets bigger, our angle gets bigger, move around the circle. Cosine of 180 degrees, or pi, moving down here, is going to be -1. Cosine of 270, or 3 pi over 2, will be 0, the x-coordinate. And full circle back, cosine of 2 pi, or 360 degrees, will be 1. So if you remember from the last video, sine followed a similar pattern, but it went 0, 1, 0, -1, 0 on those 5 values. And cosine is going to follow the pattern 1, 0, -1, 0, 1. So essentially sine and cosine look almost identical. If you actually shifted the cosine function so that it started at pi over 2, you would have or if you started it here at 3 pi over 2, you'd actually have the sine function. So if you shift the cosine, it would lay it right on top of the sine function. So it makes almost the identical loop. But cosine starts at 1 and ends at 1, and sine starts at 0 and ends at 0. And we're going to use that unit circle, those 4 degrees, or that full circle, to make one cycle and graph the cosine function. So kind of like what I showed you in the unit circle, it's going to fluctuate between 1 and -1. There are 4 standard intercepts, I just lost what I was trying to say. Those are going to correspond to these points: the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi. So here's your 2 pi, pi over 2, pi, 3 pi over 2, and 2 pi. And then cosine goes around with so it starts at 1, and it goes down to 0, then goes to -1, goes back up to 0, then goes back up to 1. Now it'll continue like that, so it'll continue on here in that same pattern and make that cycle. But one cycle of cosine kind of looks like a big U, whereas sine started at 0 and looked more like you saw more of the whole curve, where cosine kind of looks like the U, and then it would continue to follow that same pattern. This is the same as we saw in the sine slides. So cosine of x, this is, of course, the parent function. When a is 1, so your amplitude is 1, and when b is 1, which means that the period then is 2 pi. So that's what this applies to. Then our domain is all real numbers. Range is between -1 and 1. Remember that it's periodic, which means that it repeats in this pattern infinitely. The cycle is the shortest repeating pattern. That's one complete revolution, 360 degrees around that circle. So from 0 degrees to 360 in our theta. The period is what we use to represent that horizontal length of the cycle along the x-axis. The general period length is 2 pi. Our maximum height, m, corresponds to our positive amplitude. Our minimum height of m corresponds to our negative amplitude. And the amplitude is a measure of change over a single period. It's the vertical height. The amplitude in the y equals cosine of x equals 1. The equation you can use to find the amplitude, if it's not equal to 1, you can find the difference in the max and min height and divide or multiply it by 1/2 or divide it by 2. All right. So this is the same you've seen. Before I brought up the picture or the graph of Desmos of sine function, this is comparing cosine and when you change the amplitude. So you can see the blue graph is cosine with an amplitude of 1, and then the red graph is cosine with an amplitude of 2. So you can see how the amplitude changes the height or the vertical stretch of the graph. So one period of cosine goes from here down to 2 pi. So it's that U shape. And so I just want to give you a visual of an amplitude change. So we're going to sketch it by hand. So it's a little harder to see those fine details in there. The points in between and such. But to get a good sketch anyway, we're going to look at the amplitude of the period, and we're going to make a table with those 5 key points from our unit circle. So this has an amplitude of 1/2, and I get that right here from my A value. So my amplitude is 1/2. Now remember, it's to find the period, you take 2 pi and divide it by your B. And B in this case is 1 because it's just 1x. So 2 pi divided by 1 is 2 pi. So I can make my table, x, y. I'm going to need an AY column because I have an amplitude of 1/2. Or you can think, it usually fluctuates between 1 and -1. This one's going to go between 1/2 and -1/2, essentially. So my table of values always start with 0, and then I have 4 equal sections. And this one ends with 2 pi. So I have 4 equal sections along my graph, and it ends with 2 pi because that's my period. So if I want to figure out what goes in this first section, take that 2 pi and multiply it by 1/4 or divide it by 4. So that's going to give me 2 pi over 4, which reduces to just pi over 2. That tells me then what I'm counting by. So I'm counting by pi over 2. So this would be 2 pi over 2. This one would be 3 pi over 2. This one's that 4 pi over 2, which reduces to 2. I can reduce this one more. 2 pi over 2 reduces to pi. So those are going to give me my intervals along the x-axis. So 0, and then pi over 2, then pi, 3 pi over 2, and 2 pi. So these actually correspond to the 0 degrees, 90 degrees, 180, 270, and 360. Since B is equal to 1, your period is 2 pi. Those are the degrees that those are corresponding to. So if you don't have it memorized, I always refer back to my unit circle and these points along here. So this point is 1, 0. We got 0, 1, -1, 0, and 0, -1. And then they are cosine, sine. So cosines correspond with the x values along the unit circle. So starting at 0 degrees, cosine is 1. And then going counterclockwise in a positive direction to 90 degrees, we have 0. Then to -1. Then to 0. And then back to 1. So it starts and stops at 1. And then my amplitude was 1/2. So it actually is going to 1/2, 0, negative 1/2, 0, and then ending at 1/2 again. So kind of that parent function table idea that we've seen before. So cosine starts at 1/2, then 0, then negative 1/2, 0, and then 1/2 again. So here is my one cycle or one period of cosine function. So let's practice finding the amplitude and period of these. So this one has, number 1 has an 2 out front, so that would give me my amplitude of 2, which means it would be a vertical stretch. And I have a period of 2 pi because I have a 1 in front of the x. So you find the period by taking 2 pi over b, and so your period is 2 pi. So that one is the 360 degrees and the 4 typical points. Here we have an amplitude of 3, number 2, and then my b is pi, so 2 pi divided by b of pi would reduce to a period of 2. So if I wanted to divide 2 into equal force, take 2 divided by 4 and reduce it to 1/2, and that's what you're going to be counting by. So then you have 1/2, 2/2, 3/2, 4/2. You'll see that 4/2 reduced to 2, and 2/2 here would reduce to 1. So that would give you your 4 equal intervals there. So let's write the equation. Y equals a cosine of bx. The hardest part of writing the equation is the solving for b. So you need to take your period, whatever is given as the period, and set it to 2 pi divided by b, and then solve for b. And you can either multiply both sides by b and then divide, or set up a ratio and cross multiply. So here, amplitude of 2 means that I'm going to start with y equals 2 cosine, and then I need to figure out the b, so I can put bx. So I have a period of pi. So if I let pi equal 2 pi over b, I can solve for b. I can cross multiply. Oops, I didn't mean to put b there. I meant to put over 1. So then I can cross multiply and I get b times pi equals 2 pi times 1. Then solve for b, divide both sides by pi, that reduces to 1, so we get b equals 2. So it would be 2 cosine of 2x. Amplitude of 1/2, so y would equal 1/2 cosine, and then I have to figure out what my b is, so put 3 pi over 1, set it equal to 2 pi over b, cross multiply. 3 pi times b equals 2 pi times 1. Divide both sides by 3 pi so I can get my b by itself. Reduces, b equals 2/3. So 1/2 cosine of 2/3 x. If the amplitude down here is 1, it's just going to start out as y equals cosine. And then what x? So if my period is 2 pi, set that equal to 2 pi over b. Cross multiply, I'm going to get pi times b equals 4 pi. Divide both sides by pi, and b equals 4. So y equals cosine of 4x. If you have a period of 2 pi, then b must equal 1. So the numerators are the same, so b equals 1. So this one would be 1/4 as my amplitude, cosine of just x, or 1x. So the 1's not necessary there. Okay, that is it. So it's a little bit shorter. It was very similar to graphing sine. Let's say if we wanted to graph this one from up here, y equals cosine. So you can stop now if the video's over for the notes, or if you want to see one more graphing example, I will throw one on here. So y equals 2 cosine of 2x. we're going to graph this one just so you can see one more example. So like I said, notes are done. In class, if you think you've got enough information, go ahead and stop it. If you want to see one more graph, here we go. So I'm going to find my amplitude. In this case is 2, which means I'm going to go up to 2 and down to -2. And then if I find my period, I'm going to take 2 pi, divide it by b, which is 2. That reduces to pi. So I'm going to have 4 equal sections along the x-axis, and the fourth one is going to end at pi. So if I make my xy table, start at 0, and then I have 1, 2, 3, 4, ending at pi. If I want to go back to my first one, divide it into 4. So divide by 4, multiply by a fourth, and you're going to get pi over 4. That tells me what I'm counting by. So 1 pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4 is pi. And so it's going to be pi over 4 here. 2 pi over 4 does reduce to just pi over 2. Then I had 3 pi over 4, and then pi. So those are my 4 intervals. Then cosine starts at 1, 0. Cosine is the x coordinates, then 0, 1, then -1, 0, and 0, -1. So cosine starts at 1, 0, -1, 0, back to 1. So it goes 1, 0, -1, 0, back to 1. And then this one was an amplitude of 2, so 2, 0, -2, 0, -2. So it starts at 2, change back to a different color. Then it goes to 0, then -2, 0, back up to 2. So the cosine, the 1 period cosine kind of looks like the big U. Okay, so hopefully that was helpful. Follow the unit circle, identify your key features, divide your graph into force. That's what you're counting by. Max values. All right, good luck.